Okay, this is lesson 3, and we are going to talk about translating lines. We've talked in the last lesson, we learned about translating along a vector, and we saw what happens to angles and points and lines there. And now we're going to just talk about lines a little bit more specifically. So just to open this up, I'd like you to look at exercise 1, use what you know about parallel lines, and try to draw a line passing through point P that's parallel to line L. And this down here is line L. So draw a point parallel to line L, and then try to draw a second line passing through P that's also parallel to line L that is distinct or different from the first one, and then see what you notice. Okay, so pause the video now and just go ahead and do that using a pencil and whatever you have. All right, so if I was going to do this, I'm gonna use a ruler, and I'm gonna draw a line parallel. And so what I'm trying to do is just make sure that this line is equidistant from the other line all the way around. So I'm just eyeballing it. I could measure and do that. Okay, so there's my line. And so I have a new line, and I'm saying it's parallel. But if I try to draw another line through P that's also parallel, I notice that it's just going to be the same line. So I can't do that. I can't draw another one. So there's only one line passing through point P that's parallel to this given line right here. And that's kind of a fundamental thing about geometry, and it's not something we're going to prove, but you will prove it in high school geometry. So we're just kind of preparing you for that. We're gonna look at some other things in a little more depth, but we're just going to accept this. So we're going to agree that there's only one line through that point P that will be parallel to the line that we started with. Okay, what I'd like you to do now is look at exercises 2, 3, and 4 and work on those, and then we'll be having a discussion about that. So go ahead and pause now and work on exercises 2, 3, and 4. All right, exercises 2, 3, and 4 are going to give us some specific things about, these are 3 different cases of translating lines along vectors. And so let's look at exercise 2 first. And for exercise 2, notice that the vector is part of the original line. And so when I translate that, and this is what yours should look like. Now I'm going to use red whenever I'm tracing my vector. You can use the same color, it doesn't matter, but for my demonstration, I'm going to use red for the vector, and then I'll use blue for whatever it is that I'm going to be translating. So let's make line L blue. So here's line L, and I'm going to translate it along AB. So I'm going to move like so, and let me get back in my field of view. So there's my line, and so what you should notice is that if the vector, so I can trace it like this. So there's L, we'll call it L prime because it's the image, like that. So what happened was when the vector was part of the line, the line L and L prime, we're going to say they coincide, or they're the same line. Because even though I moved it over, they contain exactly the same set of points, which is what a line is. A line is just a set of points, and they're the exact same set of points, even though it's translated. Okay, so this is the case where the vector is actually my vector AB is part of L. So the vector is lying on L. Okay, so let's look at exercise 3 now. So in exercise 3 is a different case. So here we're going to translate line L, but vector AB is not on the line, but it is parallel to the line. Okay, so here's a situation where here's my vector AB. Go ahead and my line that I want to translate is parallel to the vector. Okay, so what's going to happen in this case? There's L. Okay, so we're going to go ahead and slide it. So remember, we translate, we take our beginning point and match it up to the ending point. Okay, and try to get it right here. So what we see here is that I'm going to trace my line here. So here I have like so, and there's L prime. So when the vector that I'm translating along is parallel, well, I'm going to use the symbol for parallel, is parallel to my line, then L and its image, L prime, also coincide. So we saw that it didn't need to be, the vector didn't actually need to be part of the line like in exercise 2, but if it's parallel, then the line and its image are going to coincide. Okay? So both of those are going to result in L prime being the exact same line as L. Okay, so let's look at exercise 4. Exercise 4 asks me to translate line L along vector AB. So here's my vector. Vector AB right here. And so in this case, AB isn't part of the line, and it also isn't parallel to the line. So here we go. There's L. And I'm going to translate this again. So I'm going to, again, it's a slide. I'm going to slide my overhead up so that my starting point becomes my ending point, matches up to the ending point. All right, so now we have the image of that line is right up here. So this is L prime, and I'll trace it right here. L prime. And so notice what happened here. So this vector is not part of the line. So vector AB is not part of the line, it's not part of L, or parallel to L. But L is parallel to L prime. Okay, so it resulted in my image, L prime, being parallel to the beginning, to my original line. Okay, now take a few minutes to do exercises 5 and 6. Look at what they're asking you, and then do the exercises. Pause the video now, do that, and then come back and we'll discuss them. Okay, so exercise 5 doesn't even tell us to translate anything. It just tells us that line L has been translated along vector AB. Here's our original line. And it results in this translation, or this image, L prime. and we're asked, what do we know about L and L prime? Well, from the exercises that we just did, we have, and we didn't formally prove it, but you will do more formal proofs in geometry. What we know is that L is parallel to its image, L prime. We could also write this, L is parallel to T of L if T is my translation along vector AB. So that's what we know. Okay, so let's look at exercise 6. And this may have surprised you a little bit when you did this translation. So this looks a little different than the translations we did in exercises 2, 3, and 4. But hopefully you found something that's common here. So here's my translation vector, DE. And I'm asked to translate a set of parallel lines. So this is line 1. Call it L1. And here's line, this is a different color. Here's line 2. We'll call it L2. And these lines, of course, go on in every direction, don't they? But they're not always drawn with the arrows on them. But it's an entire line in the plane. Okay, so we're asked to translate both of these images along DE. So we can do this in one movement. So I'm going to slide D so that it coincides with E. And I'm going to try to make sure I did it along that line. Okay, so there are my images. So I'm just going to lift up my overhead and trace them. So line 1 is right here. So I'm going to call this L1 prime, and line 2 is right here. This is L2 prime, the image of L2. Okay, so we've drawn them. We were asked to label the images of the lines, so we've done that. And if lines L1 and L2 are parallel, so we're told if L1 is parallel to L2, what do we know about the translated images? So what you might realize is that L1 prime is parallel to L2 prime. My images will also be parallel lines. And it might be good for you to think about the reason for that. You could kind of, I know that L2 and L2 prime are parallel, but L2 and L1 are parallel, so therefore this L1 has to be parallel to L2, and we could go through the same line of reasoning to realize that all 4 of these lines are parallel to each other. So therefore, the images are parallel to one another. This seems obvious, but it's going to be used in proofs when we're trying to prove things about shapes and images that get translated, and of course congruency when we're trying to prove that 2 images are congruent to one another, or that they are same size and shape. So this is going to be a really important piece that we can use as we do that. Okay, so let's look at the problem set just to summarize this lesson. We'll have you do the exit ticket, but let's look at the lesson summary together. So this is on the problem set page. 2 lines are said to be parallel if they do not intersect. And so that's something that we assumed from what we knew before. And we saw that in the first exercise, this last one, given a line L and a point P not lying on it, there is at most one line passing through P and parallel to L. So we saw that. That's going to be important an important thing that we'll use in proofs. And then translations map parallel lines to parallel lines, and we saw that in this exercise. Okay, so we had a set of parallel lines, L1 and L2. They mapped to a new set of parallel lines, L1 prime and L2 prime. Okay, so in your exit ticket, you're asked to perform some translations of points and lines, and then in both of those, and then asked what you can know about the translated figures. Okay, and then in your problem set, you have angles, lines, and a quadrilateral that will all be translated along a vector, and you'll be sketching and labeling everything that you translate, and then asked to think about what you know about those translations. So that should be pretty quick and a good exercise for you. Okay, that's lesson 3.